Hello everyone, welcome to Hill Studios again. This is G Sanjay Verma, and today we will discuss about joints. And joints are one of the most important stuff and one of the most amazing stuff which is available in Unity. So joints are really used for connecting two objects physically. What is the meaning of that? Like let's say I have a cube and I have another cube which is like child of that cube. If I if i let me say, like, if I change physical properties of the parent cube, right, it doesn't necessarily affect the child, but if I want the child to also behave like parent, like having rigid body, all of this kind of stuff, then I need to add joints. There are different kinds of joints like fixed joint, hinge joint, spring joint, which will enable the different properties throughout the child objects of a parent object. And don't get too confused, we will talk about them. And now initially we will talk about fixed joint, and we will see how it works. Okay guys, now we will talk about fixed joints. Initially there are three kinds of joints. First one is fixed joint, next is hinge joint, and next joint is a spring joint. So initially I made a kind of platformer where the starting cube is the base, where the ball is right above it, and the last one is like ending base, and you have three cubes in between, and you can see like sphere is floating above, going above through that one, which is nice and good. And now what we can do is we have three cubes in between. Those three cubes will be exerting some kind of weird physics right now. So let us see that one right now. Now we will go to components and we will try to add fixed joint right now. Okay, let me tell you what is fixed joint initially. Fixed joint will override our rigid body. What is the meaning of that? So if there are three cubes and if those three cubes have gravity enabled, if I enable fixed joint, then those three cubes will not have rigid body. I hope you guys get it. Like, fixed joint will override the rigid body. In fixed joint, you have a property known as break force. What is the meaning of that? Like, if any force is being applied on that cube, then fixed joint will get destructed during runtime and rigid body will start applying. So this is the main concept behind fixed joint. So let me explain to you right now. Let us see, I have a fixed joint on it, and I applied a force of 0.001, and I don't have connected body, and my connected body is none. What that means is, like, my object is being connected to world. So what that means is, like, whenever it is connected to world, there is a gravity force. So on those three cubes we will have a gravity force of 9.8, but what is my break force? It is 0.01. So that is the reason my cubes started falling down. Why my cube started falling down? I hope you guys get it. Because we don't have a rigid body, we are connected to outside environment, where outside environment will exert a force of 9.8 meter per second, that is gravity force. So if you have a break force of infinity, then fixed joint will never remove, so rigid fixed joint will successfully override rigid body. But if you have a break force of let's say 0.001, then gravity force, which is 9.8 meter per second, which is very very high, then 0.001, then fixed joint will get destructed. So how it can be useful? Let us assume, like, you have heard about some kind of puzzle games where user, once he steps forward, he can never go backward, so that the entire path should be destroyed, right? So what you can do is you can just set break force with some appropriate value, such that when the sphere lands on that particular cube and is exerts a force at that particular point, the particular cube should start having rigid body and the fixed joint will get destructed. Then what happens is that the cubes will fall down and user cannot go back. And let me demonstrate it to you right now. Now let us see, I applied a break force of 10 right now, and whenever sphere falls down, the middle three cubes will also fall down. Why? Because sphere will exert a break force greater than 10. So if any force being applied on the cubes greater than 10, then fixed joint will get destructed during runtime and rigid body will get applied on those cubes, guys. So what happens if there is no sphere? Then they will not fall down, because gravity is applying 9.8 meter per second kind of force, and 10 is of course greater than that. So gravity will never break those cubes. So this is some of the applications where you can use this fixed joint. And I hope you get some good clarity on this one. You can also just watch the inspector when the cubes fall down. You can see like fixed joint got distracted during runtime. If you just missed it, you can just watch it on this on just you can just rewind and you can just watch it on fixed joint will get distracted during runtime. So fixed joint is like a runtime kind of stuff which will block the rigid body from happening, and if there is some weak force or if there's some brake torque, then it will get distracted. Now, okay guys, now let us talk about one of the properties known as connected body. So if there is no rigid body which is dragged onto the connected body, like if it is not connected to anything, that means it is connected to world. What is the meaning of that? So world is like applying a force of 9.8 meter per second. So I'll take our base cube and I'll add rigid body to our base cube, and I'll also add use gravity option, and I will also I will drag that base cube to our connected rigid body, and if you can observe right now, the three cubes are moving, but our main cube, base cube, is not moving at all. So let us go back to our main menu, and let us try to enable let us disable ease kinematic option on our base cube. Now what happens is that since we have rigid body ease gravity option enabled on our base cube, so our base cube falls down. Since all of the three cubes are connected to our base cube rigid body, all of the three cubes will also fall down. So do you get it? Like if one cube is applying physics, then all of the cubes which are connected to that one will also apply physics. So you might have a case where there are like 4 to 5 different objects which are physically connected to another object. Like if one object falls down due to gravity, or one object gets interacted to other object, all of these objects should also get interacted, right? So that's what happens here. They are so one object moves physically. If you apply force on one parent object, all of the objects connected to that one will also apply on this one. Let us look at some of the parameters right now. Brake force, you already know that one. It is the maximum force to just make it is a force at which the fixed joint get distracted. Brake torque is like torque is the rotation kind of force. So if you just apply 10 kind of stuff, if you apply some kind of rotation force, if it is greater than 10, then fixed joint will get distracted. So let us look at some other concepts right now. And there is like something like enable collision. You can detect the collisions as well, at mass scale and connected mass scale, enable pre-processing. All of these kind of additional options, you can just leave them as defaults, and you can just take them out if you really want it out. And I hope you guys got some value out of this fixed joint. Fixed joint is a kind of a procedure where you will like to override the rigid body. And now we will look at some other joints right now, and now we will look at spring joint. Okay guys, now we will talk about the spring joint right now. Initially we have those three cubes right now, right? So when we look at those parameters, it is known as a connected body. We have none. So what is the meaning of that? Like all of those three cubes are connected to like a wall, right? So they will have a force exerted like a gravity force of 9.8 meter per second. Now when we hit play, you can just see like those cubes are connected to wall, and they are rotating around the wall. Now what I need is like those three children should be connected to the base cube, actually making sure like the base cube physics will also get applied on the children as well. That's what we need initially. So what I'll do is I'll just take those three cubes and I'll take the base cube and I'll add its rigid body to our connected body parameter. You can just see right now. Now I'll try to add them out, and I'll hit play right now. We'll see what will happen. Now you can just see like the cubes are connected to our base cube right now, which is kind of cool. But you can just observe like there are points, but just kind of stuff, brown color, those are known as the anchor initially, and they are at the center of our cube. But when we have a bridge, the bridge will have two ropes on either sides of the bridge. So what we need to do is we need to have anchors on either side of the cubes so that they get balanced. So each spring joint will give me only one anchor point, so I need to add two spring joints. Each spring joint will give one anchor point. So I'll add one spring joint anchor point to the one end of the cube, and I'll add another spring joint anchor point to the other end of the cube. So what will happen right now is our bridge stays balanced, and we will have our equal force exerted on both sides of the stuff so that it remains balanced. Now let us hit play, and we will see what will happen. And make sure you have same parameters on both of those spring joints actually. So let us hit play. now you can see like they are kind of balanced, right? They are not rotating around center and they are kind of balanced. But one thing that you can observe is like the anchor points are quite far away from our actual cube. Like our cube is somewhat distant from anchor cube, so we need to be somewhat closer to our base joint. So what you can do is you can just manipulate the value of spring value. When you increase the spring value, our cubes get closer to the anchor point. Just make sure like where you increase the value on both sides of both spring joints initially, because you have two spring joints on each cube. I'm trying to find a value right now in between 200 to 50, something like that, and just make sure change the value when you are exiting out of the play mode. So if you increase the spring value, then our cube gets close to our anchor point. And damper is a kind of a property of spring. Actually, I don't want to go into that. Actually, if you just want, you can just look into the internet and what does damper does. And minimum distance is like the minimum distance traveled by the spring. Maximum distance is maximum distance that can be obtained by the spring. Tolerance is like a error in the movement of a spring. If you want, if you need to have some kind of rigid kind of motion, you can increase the tolerance. You can just see like I added a spring of 70 to all of these three cubes. Now they are fixed to the anchor points. They are not moving down to the anchor point. You can just observe here. So and after that, you can, I also explained some of the properties. Right now we explained connected body, and there is also brake force and brake torque as well. Brake force is generally applied if let's say assume like this spring joint will also try to override rigid body. If there is a force which is being applied on those cubes greater than the brake force, then that particular spring joint will get destructed. So that is the main purpose of joints. And you can also look at different kinds of parameters if you want in Google, in Unity forums or Unity docs mostly. And brake force and brake torque and minimum distance and maximum distance, I hope you get them. And damper is also a kind of parameter which will try to tell us like how much the like spring should be reduced. And enabling pre-processing mass scale, connected mass scale, you can also check them out, but leave them as default if your purpose is being served right now. So this is about spring joint, guys. And fixed joint will not which like a fixed kind of joint which will try to make sure like it is stay fixed, like it is equal to is kinematic if you say. And if you look at spring joint, they will try to apply spring property to a couple of child objects, and that is really quite cool actually. So now what we will do is we will look at hinge joint right now, and we will look at hinge joint at the next video. Thanks for watching up to now. Please make sure you like the video if you like it, and subscribe it so that you can get more